Hey everyone, my name is Melanie. I'm the Math Content Specialist here at Zinkers. Let's take a look at another digital SAT question and how we can use Desmos to help us solve it. This question says, in the given system of equations, A is a positive constant. The system has exactly one solution. What is the value of A? Our system here is y equals negative 1.5 and y equals x squared plus 8x plus A. So what we know about those two lines, just right off the bat, is that this is a horizontal line, which I'll graph in a second, and this is a quadratic equation, so it'll look like a parabola type shape. The thing that we're solving for here is the value of A, which is this value right here. And if you recall from what we know about parabolas and quadratic equations, this value here, this constant value, is our y-intercept. So this will be a piece of information that I will use later just to check our answer. So now I will jump over here to Desmos, and I'll type in both of my equations. So y equals negative 1.5, again, is just a horizontal line here. And then my second equation, y equals x squared plus 8x plus A. I can actually type A right into Desmos, and I am going to hit this button right here. It says add slider for A, and this just allows me to play with, move around that value of A. Experiment with what happens if A is 1.7, for example? What happens if A is negative 3.2? I can mess around and see how that affects or changes my parabola. So a couple of things to note here. They did tell us that A is a positive constant, so I should be sure to only be looking at positive values of A. And then also, the system has exactly one solution. This means that these two lines intersect at exactly one place. So just a couple of things I'm keeping in mind as I take a look at these two lines. So I'll just kind of click this input here and then just set some boundaries for my value of A. Because it's positive, I am going to type in -1 here, just to kind of take a look at it, but I am keeping in mind that A is positive. And then just to set a boundary, just for the sake of a number, I'm going to pick 20, just kind of a bigger number. And then my step, I'm going to put in 0.1, just so that I can mess around with values, with decimal values, and just, again, see what those look like. And once I click away, I should be bounced back to my little slider. And now I can play around with that value of A. And what I'm looking for here, my goal is to see what value of A is going to give me a system that has exactly one solution. When I move around this slider, I want that parabola to intersect that black line at exactly one point. And that should happen right there at that vertex. So right here, somewhere down at that point. So if I play around, I can see, all right, if I decrease the value of A, I'm dropping that parabola down lower. And if I increase it, I'm bringing it up, which is going to help us here. If I want to bring it up to that line, I should keep going until I see it intersect at exactly one point, which should be right around, doesn't want to get me there. Let's see. So sometimes Desmos can be a little bit fidgety. I'm just, again, checking to see this is touching at exactly one point, and that's going to happen at A is 14.5. I can see if I hover over that spot, it's just one intersection, this point here, -4, -1.5. Again, we're checking the value of A, not the solution, right? Not this XY ordered pair. And then I mentioned earlier that my value of A is also my y-intercept. So if this is in fact the correct answer, I should have that my value of A is also going to be where this graph crosses the y-axis, and indeed, it does cross at 14.5. So I've checked off both of my requirements here, or really all three of my requirements. A is a positive constant, we have that. My system has exactly one solution, we're intersecting at exactly one point, and then just double checking that that value of A is also my y-intercept, which is happening up here. So therefore, the answer to this question is going to be A equals 14.5. Is there another question that you want to see? Make sure to leave a comment down below, and don't forget to like and follow for more digital SAT content.